Welcome everybody. Thanks to you for coming. This is the Collaborators Webinar for the Spatial Decision Support and Open Knowledge Network team for our NSF project. Hopefully all of you are aware briefly of the project and what it's about. We're going to get going here. First off though, before we jump into things as far as some of the logistics, if you need to connect with an alternate audio, here's a slide about it, and then if you have problems with that, we can come back to that real quickly. And also the webinar is being recorded. And so what we're going to do here is we're going to try and hit as many of these objectives as possible, as deep as possible. But when we thought about having this webinar, we really just wanted to convene the collaborators from the 3 different use case groups and some of the national level efforts, and give people a chance to get together and have a short discussion, hear each other's voices, have a little cross-pollination among the groups. Also to present a draft conceptual framework to demonstrate our emerging technology, receive feedback on these things, and talk about next steps for the moment and for phase 1 and 2. And so what we're going to do is we're going to go through introductions briefly, and then talk about that conceptual overview, go into the demonstration of the prototypes and slides, have a discussion, and talk about next steps and in closing. So what we'll do is very briefly introduce our team. At its core, our team is the Spatial Decision Support Consortium and colleagues. The Spatial Decision Support Consortium came together over 10 years ago to start addressing this need of having some coordination and communication among all the different experts and practitioners in the field of spatial decision support. And so last year we co-wrote a proposal to NSF for this Open Knowledge Network program, and we were successful. And this is an overview of our team. It's just a fantastically rich group of just incredibly brilliant people. A very large team, one of the largest that most of us have worked on an NSF project, and we meet weekly and have a lot of cross coordination. So on the call today are the 3 leads of the case study groups. My name is John Gallo. I'm the lead of the Biodiversity Conservation case study group, and I work for Conservation Biology Institute. And what we're going to do is give people a chance to briefly introduce themselves, both that are on the team that are presenting today, Mike and Philip, as well as in the next slide we will give a chance for everybody on the call to say their name and their organization briefly, as a chance to do a mic check, and also have people hear each other's voices, and maybe the discussion will be that much more rich. And that is if we have time. We have about 10 minutes budgeted for this, and we're already a few minutes into it. So while I make some screen grabs of the people on the call, I want to pass things over to Mike and then Philip to briefly introduce themselves and say anything else about our team.
Thank you. I'll put on my video. Yeah, it's on. Oops. Sorry. So I'm Mike Flaxman. I have a little consulting shop called Geodesign Technologies. As the name probably indicates, I'm interested in applying technology to land use and landscape planning. I have a background in biology and in GIS technology, and taught at MIT for a number of years in the planning group called Department of Urban Studies and Planning.
Okay, Philip.
Okay, yep, sorry, jumping in. This is Philip here. I don't have a camera, so I'm afraid I'm going incognito. I'm based here in Seattle. I have a small company called InfoHarvest that is both a software producer and also a consulting company. Our core obsession would be around all things to do with decision making and decision processes. I've been working on natural resource efforts now for almost 2 decades. Okay, Sono, do you want to jump in?
Yes, I'm Sono Hashisaki, and my company is Springwood Associates, and I'm a tied at the hip partner with Philip Murphy working here in Seattle in the Puget Sound. So welcome.
Great, thank you all. I'm almost finished here with the screen grabs. One of the problems with Zoom meeting is that they don't organize all the participants in alphabetical order on the same order for everybody's slides. So let's see, I think I was able to do that while we were talking. Let's see if that worked. This project's all about innovation experimentation in process. So, and it's not updating in real time since I'm in visual production mode. So, okay, so I got to go out of presentation mode and back in for it to auto update. So the next slide is talking about the Spatial Decision Support Consortium. We have a web page. I encourage you to check it out. It also has a knowledge portal. And so that is an exciting page to check out if you have not. So now I have gone out of presentation and back into it. And there we go, good. All right, so our use cases are, as I think everybody on the phone should know, we decided to make this project real by not only doing user-centered design, human-centered design, but also focusing on 3 different themes that are water quality and wildland fire and biodiversity conservation. And we focused on different regions, different groups of people, as you can see on the slide here. We had our initial 3 themes and 3 locations, and we've since added a biodiversity conservation element in the Central Valley and a fire management element in Santa Barbara County, as well as a couple national use cases, one on habitat connectivity and one on citizen science. So let's go ahead and first, Sono, can you tell me, it's time check, how much time do we have for this introduction? Do we have 8 more minutes? I don't have it memorized. And I can look over here. So actually we have 5 more minutes, 5 minutes for this introduction. So we're going to start with Jonathan Long. And Jonathan, if you can briefly say your name and organization. And if you want, you could also mention which of the 3 themes was your entryway into this. I will note that in the future, we're moving towards the whole integrated use case team. So that was an entryway. And then we should probably move on through everybody. And everybody can turn on and off their mic. Hopefully you can see how to do that. If you have problems, just let us know in the chat. All right, Jonathan, take it away.
Yeah, this is Jonathan Long. I'm with the U.S. Forest Service Pacific Southwest Research Station. And I think I got drawn in on the fire dimensions, but I'm interested in the integration across different topics. Thank you.
Okay, we already heard from Mike. Did we hear from Mike? Yeah. And moving right along.
This is Phil North. I work for the Tulalip tribes in Washington, and I'm working with Philip and Sono on applying this kind of technology here for projects that we're interested in. So I'm listening in so I can keep up to date.
Thank you. Colin?
Yeah, Colin Hume with the Washington State Department of Ecology, and I've been collaborating on the Puget Sound water topic.
Great. Catherine?
This is Catherine Wyatt in the Science Division at the Puget Sound Partnership, which is the state agency that coordinates the restoration of Puget Sound. So interested in the water component and how to use this tool in scenarios.
Thank you. Keith?
Yeah, hi, Keith Reynolds. Can you hear me okay?
Yep.
So I'm a research forester with the Pacific Northwest Research Station in Corvallis. One of the members of this project, one of the co-PIs, and assisting with both Mike Flaxman and John on a couple of the case studies.
Thanks. Tom?
Yeah, hi, this is Tom Newald. I'm with the U.S. Fish and Wildlife Service. I'm a conservation planner out of Portland, Oregon, and I've been working on the biodiversity piece with John and the Cascades to Coast Landscape Collaborative.
Great, thank you. Anna. Oh, Anna, you're on mute. Oh, good.
Oh, no, yeah, I'm on now. So Anna Olson, Consumer Resource Conservation District. We're working with John on the fire component down in Santa Barbara County.
Thanks. Ann?
Hi, this is Ann Edwards. I'm a conservation ecologist with Resilient Earth Consulting. I'm also on the leadership team of the Cascades to Coast Landscape Collaborative. So interested, or the portal is through the biodiversity element.
Great, thank you. Jim?
Hi, I'm Jim Strittle. I'm Executive Director of the Conservation Biology Institute in Corvallis, Oregon.
Great, thank you. And Diana? It sounds like you're on mute. Or let's come back to Diana. Jennifer?
Hey, nice to meet you. Jennifer Bernstein. I teach full-time at the Spatial Sciences Institute at the University of Southern California.
Thanks. Jackson?
Hi, this is Justin. I'm from New Jersey Institute of Technology. I'm a graduate student in the technology team.
Great,
thank you.
John?
Hi, this is John Payne. I'm an ecologist. I've worked a lot in population and spatial modeling, and over the last couple of years I've gotten really interested in AI, and so I'm here just because I'm interested to see what other people are doing with it.
Great, thank you. Karen?
Hi, Diana, are you on now? No, okay.
I think I am. Yeah, this is Diana Sinton. I'm the Executive Director for the University Consortium for Geographic Information Science. We're working on having our body of knowledge be one of the horizontal use cases within this project.
Great. Karen?
Okay, now I'm Karen Kemp. I'm President of the University Consortium for Geographic Information Science. I'm also a Professor Emerita of Spatial Sciences at USC.
Thanks. Carl?
Yeah, Carl Palmer with Legacy Works Group, working with Anna Olson and Sharon Main, who are also on the call here on the fire use case in Santa Barbara.
Thank you. Patrick?
Hi, this is Patrick Huber. I'm a researcher at the Agricultural Sustainability Institute at University of California, Davis. And my colleague Alan Hollander and I have hooked into this project to help design the ontologies, and we're especially focused on the biodiversity component, specifically in the Central Valley.
Thank you. Phoebe?
Hi, good morning, everybody. What a great team. I'm Phoebe Barnard. I work with John Gallo and Jim Stritholt at the Conservation Biology Institute, global change ecologist and conservation biologist by background. My overriding interest here across fire, water, and biodiversity is in accelerating the ability of governments and others to make decisions using tools and paradigms such as this, and also to help them make decisions about multiple complex simultaneous problems in the environment resulting from global change. Thanks, John.
Thank you. P. Williams.
Hi, this is Paul Williams. I'm a shellfish biologist at the Suquamish tribe and now working mainly as the policy coordinator. And our interest is using data to deal with the issues in Puget Sound.
Great. Rob.
Hi, Rob Crable, Northwest Representative with Defenders of Wildlife. I'm also on the leadership team of the Cascades to Coast Landscape Collaborative, and really interested in the biodiversity aspects.
Thank you. Sean.
Good morning, folks. I'm Sean Gordon at the Institute for Sustainable Solutions at Portland State University, and I'm the principal investigator for the project, so try to keep things coordinated.
Thanks. Sharon.
Hi, this is Sharon Main. I'm with the Community Environmental Council here in Santa Barbara, working with John, Anna, and Carl on the Santa Barbara County fire case study. Also particularly interested in the integration of fire and overall climate resilience. This is really going to help us in terms of looking at better coordinating our network around climate resilience. So very excited to be part of this.
Thank you. CJ.
Good morning, everyone. This is Sujay Wang. I'm a PhD student in Arizona State University. I'm doing research in one group. My main research interest is information retrieval and 3D visualization related to geospatial data sets. And I'm also doing some Turing data sets recognition using some deep learning technologies. Thank you.
Thank you. Steve.
My name's Steve Pavlanis. I'm with Mountain View Business Group. I'm working on a project trying to unify the different technologies within this group and to use tools to assist with building and searching workflows and ontologies and all the other fun things.
Great, thank you. Tim.
Good morning and good afternoon. I'm Tim Nyergis with GeoInfo LLC. I've been a faculty member at the University of Washington for 35 years, specializing in systems integration and participatory decision support. And I'm the founding president of the Spatial Decision Support Consortium.
Great, thank you. Tyler.
Hi, this is Tyler Creech. I'm a spatial ecologist at the Center for Large Landscape Conservation in Bozeman, Montana. And I'm interested in how this work might be applied to connectivity conservation. Thanks.
Thank you. Yuan.
Hello, this is Yuan Tian from Arizona State University. I'm a PhD student working with Dr. Wenwen Li. So I'm working on the ontology building, especially with Philip and Alan, Natong, and Tim. So yeah, thank you.
Great, thanks. And has anybody joined the call while we've been doing introductions? Okay, very good. Well,
yeah, this is Derek Day. Sorry, I was unmuting myself.
Okay. Great. So Derek, you want to just briefly introduce your name, organization, maybe what of the three themes brought you into the project?
So my name is Derek Day, and I am with the Washington State Department of Ecology. I do Puget Sound scale stormwater recovery planning, and I am interested in kind of the intersection of all of these.
Great, thank you. And YHZ arrived. You want to briefly say hi, your name and organization? YHZ is on mute. So when you have a chance to unmute yourself, you can just chime in when you're able to do that. And that actually, it could have been one of us renaming. All right, very good. And in fact, yeah, it looks like it was somebody that's on the call. Maybe the 360-485-3905 number. So yeah, and Philip, you're the Zoom meeting expert. If you have any insight on that, that would be great. But I think we should just move on. We have 6 minutes to catch up on in this next section to stay on track. So I'm going to keep rolling and get going with it. It's just a really fantastic group of people. This is working out. This is exactly the size we were envisioning, and we'll just put it into left it up to just fate to try and make it the right size. So thank you all for coming. And so what we're going to do is just jump right in here a little bit more. One of the questions on people's minds I want to try and address up front is like, what is the timeline? Where are we at? So real briefly, we are in phase 1 of the project. This is the $1 million phase. And we've really been focusing on the human-centered design aspects in the fall and building the working prototypes now. and having this little collaborator webinar we just threw in there as a bonus. And then we're having the national workshop on March 4th at 10 a.m. You all are invited to that. More details are coming. It's going to be a bit more interactive than this. It's going to be a 3-hour session with some breakout groups and some big heavy hitters in the field that we're talking about. And we're really hoping to blend that, bridge that science and practice divide further there. Then our phase 2 proposal is due sometime in mid-April. We still haven't received the RFP. In that, we're going to have letters of collaboration, hopefully from many of you, in ways that we can all find collaborative approaches, and we'll circle back to that at the end of today's meeting. And then in mid-May, we have to give a 10-minute pitch to the NSF team and other judges that will be there. And so they've been encouraging us to start really thinking about what's the story of our project and how to convey that in a 10-minute style pitch. It's kind of like a TED Talk-esque kind of approach. And then hopefully we get phase 2 grant, which is $5 million for 2 years for research and development and delivery. We're going above and beyond, and we're actually delivering a working prototype in phase 1. But we're going to be delivering a much more robust stack and set of tools in phase 2. So what is the story? So what we have here is a draft of a story that we could use to frame this project. It's just still in the creative stage. And it's a draft for this webinar. It's a combination of a few different framings we've used in the past, and feedback is welcome. So what is the trend of human-environment relations? What is that trend? Where are we going with our relationship with the environment? Well, there's a growing consensus that the trend of human-environment relations is in the negative direction. The metaphor is that our house is on fire. We must learn to make these decisions under conditions outside the modern human experience. The chart on the left is one that most people should be familiar with. That's carbon dioxide that we're pumping into the atmosphere. We are way outside of the natural norm, and we are turning our planet into a greenhouse. And with the increasing carbon dioxide levels comes increasing temperature, as well as all the other things like the global extremes of weather and sea level rise and all of that. And so this failure that we're, I will be so bold as to say, and Mike, thank you for dolling up the slides too. We'll be so bold as to say that this failure to enhance the decision-making consequences is having harsh consequences, or to be softer, it will. So we need to get our act together. And but fortunately, we're at a kind of a fork in the road here, at least in the US. Social scientists are documenting a profound shift in the American public. Here's one of several such studies. There's now overwhelming consensus that climate change is real, is man-made, and is an urgent threat. Anecdotally, climate change was the #1 issue this week for 28% of the voters in New Hampshire, second only to healthcare. That's according to a CNN poll that just came out. But we got to keep in mind too that the climate crisis is just one of many indicators of our negative trend with the environment. The biodiversity crisis is another. The world has lost over half of its wild animals since 1970. Here is a great slide of what's going on with water. If you look all over the world, clean water is becoming more and more of a commodity. And so it's like our ability to monitor change is improving, but we must go beyond that. Right now we're documenting the decline really well, but we need to go beyond that. Here's just a quick skinny of this is that green is good, red is bad, and 1999 is the left-hand side of this chart for a variety of different locations looking at water condition index in the Puget Sound, and 2014 is the right side. And so you see a lot more red on the right, red and orange. So how can we reverse this negative trend in human-environment relations? Well, one of many strategies, and one that's been kind of the career strategy of most people on the call, is to harness, on the team, and probably on the call, is to harness science and technology to help us as a society make wiser decisions. Now, there is a whole science behind decisions, decision science, and a key part of that is known as the knowledge pathway or the knowledge ladder. And essentially, it's important to keep in mind these different breaks. It's a continuum, but you start with data, which is largely made up of observations, which can be synthesized into coherent pictures and ideas known as information. And the information that provides evidence for that hypothesis or conclusion is evidence, and that synthesis of evidence can help provide understanding and insight. And when you combine that knowledge with morals, you get wisdom, and you get those wise choices that are going to lead towards reversing that negative trend that we have. And so our organization and our expertise has really been focusing on one aspect of decision support, namely spatial decision support. And it's a specialized aspect of decision support in which we're able to really help with these decisions about what to do where. So we really had a big breakthrough with it in the 1980s with geographic information systems becoming available. And then in the 90s with public participation, taking that to a whole new level. And then in the 2000s with web platforms. But now we're at the point where we're at this point where it's just so hard to handle all of the complexity that's going on. Spatial decision support reaches limitations when dealing with hugely complex and connected systems like human-environment relations in a region. Now it's like almost beyond what people can think about. There's calls everywhere in the literature and by practitioners for people, organizations, and agencies and academic disciplines to break out of their respective silos and to work across domains. But with the immensity of knowledge available for any particular domain and limited budgets and project cycles, this laudable goal becomes a nearly impossible task. An image that illustrates how all things connected in a very complex manner is here. And eventually we have the vision of actually having 4 corners of this screen, one of the complex food web, one of the biodiversity water cycle, one of fire, and one of like human processes, and then overlay all 3 of them in the middle to make a mashup of incoherence. But this one was a great placeholder for now. And so, thanks Mike, and thanks Sean. I am new to Google Slides, so I was using my notes page thinking that you guys couldn't see it. So thank you. Now, moving right along. Fortunately, in our strategy of harnessing science and technology to make better decisions, we're in the midst of exponential growth in computing technologies and the dawn of machine learning and artificial intelligence. Here is a chart that is kind of embodied by Moore's law, but basically we have exponential growth. The y-axis is a logarithmic axis, and this is the number of transistors in a computer, basically, or in a computing system. And it's an extension of that concept. But the idea is that we're in exponential growth. And the part of the slide that's not showing is this arrow right here is the brain power of a mouse. And okay, so the brain power of the mouse comes in somewhere in here. We've already passed the brain power of a mouse in a laptop computer. The brain power of a human is supposed to be at about the year 2023. And here at the year 2045, it's supposed to, the brain power of a typical computer is going to be the same amount of brain power as the entire human race combined. So, startling statistics. But there's obviously some uncertainty there depending on the analysis that you look at, but the trend is clear. And so rather than running scared from this revolution or letting it be driven by commercial applications with shareholder profits being the primary objective, we have the opportunity to also engage this revolution in spatial decision support for human-environment relations. And this is where the Open Knowledge Network can come in. The Open Knowledge Network is a network consisting of partners across academia, industry, and the government, set out to foster the publication, retrieval, and integration of openly available knowledge. Such a network may also foster a culture of opening up otherwise siloed knowledge. And I'll point out that that is a definition that is being created by our entire cohort of Open Knowledge Network teams. We're one of 19 Open Knowledge Network teams, and we're linked with another 30 teams that are looking at leveraging this technology for jobs and that type of education. And so that brings together our conceptual frame in this slide that illustrates the three concepts we just outlined. And so it's this intersection of human-environment relations and spatial decision support, now bringing in Open Knowledge Network. That is our project. And so this is where we're choosing to focus our energies and to frame our ideas. And so a way of conceptualizing that visually is that in the old days, we had lots of challenges dealing with human-environment relations, and we would communicate with each other within our different roles of scientists, stakeholders, and decision makers, as well as among the different roles. And any individual person could play different roles at different points of time. Now, with the Open Knowledge Network and web-based GIS and all of that, we now have a wealth of resources and tools at our disposal. So we just need to build them and to develop them. And so now we have this cloud-based approach that is able to incorporate human values, knowledge resources, policy goals, norms, and funding, and actually be able to start linking them all together in coherent ways and be able to then provide it back to us in a filtered and much easier to ingest form. Because I don't know if you guys have noticed, but there is a lot of information overload in our society right now. And the challenges, the special challenges in this, not only is it in just search of data and text itself, but the spatial search is especially far behind the curve. If you go to Google, you get a pretty good result when you type in a text-based result. But when you start doing spatial search, it's just essentially broken all across the web. And there's quite a variety of challenges there. But in essence, we've got GIS and satellite data not being easily discoverable because the search is based on handwritten metadata interpreted as keywords. So oftentimes you want to find something within the data set, but that's invisible in the metadata. And then also the wealth of data is so big and so vast. Just to give you an idea what's going on, we've got public data coming out weekly, 1.6 terabytes of data for one data set. It's just a remote sensing multispectral data set. And we're getting a private data set, which is daily, and that's 28 times bigger. So replicating this in semantic forms is not feasible. So that's kind of the advanced challenge. And then also spatial decisions are beyond polygons. It's not just about maps, it's about people. And you consider historical data, future scenarios, a variety of methods, working within organizations, within legal and institutional context. And it just becomes overwhelming. That picture of the people looking at that crazy blackboard comes to mind. So the semantic web is going to help us directly express these concepts and relationships. And so an overarching research question that's in draft form is, how do we better include spatial decision support for human-environment relations into the Open Knowledge Network? And before I get into just a little reminder, a bit more of the Open Knowledge Network, let's just do a quick time check. I was expecting to hear a little buzzer. Just so everybody knows, when you hear a little ding, it means we're out of time for that particular component. Good. So we actually have 5 minutes here. I'm thinking it might be more important to have quick comments rather than a primer. Most of you should have seen a primer from me, Mike, or Philip in the last 5 months about the Open Knowledge Network. Here's my little primer. Basically, if you do Google search on detailed things, you're not going to get your answer. And if you do spatial search, you're really not going to get your answer. And there's a whole bunch of challenges to that. And one way to do it is to build triples. And these triples can be a part of a big knowledge graph. And knowledge graphs can be represented like this, but they're really much more complex than that. You can have a 3D knowledge graph that you can then interact with and you know, move around with, and it's just you're able to browse through things, click on them, have all sorts of different data represented, and that's just you as a human interacting with it. The great thing about all this is that artificial intelligence, machine learning, and AI, you know, and those types of tools can also interact with all of this information. So let's see. That's not looking right now. So that's that. So now let's break for a little bit of discussion here for another 4 minutes. Any comments, feedbacks, thoughts, questions? And don't be shy.
So we really want collaborator feedback if possible here. But of course, one of the biggest issues in front of us here is how do the collaborators feel about that research question? John, can you go back to that research question?
Yeah, I can. Google Slides is having a hard time, but let me just pull up another version of it.
I think it's okay to keep moving and show the tools. People probably have feedback on the tools as well. But
yep, we can definitely bank our time. So just so people know, we've budgeted a fair amount of time for discussion and questions. So I encourage you to pull a little piece of paper on your desk and just start jotting down questions or comments as they go by. But now that people have had a chance to think about my spring-loaded question of any comments to date. Any thoughts right now? Okay, and that's understandable because we're all just thrown together on a call for the first time, and there's a lot here. This is new things. Some of it's unsettling. You know, it's just kind of the world we're in and the trajectory we're on, and I understand that feeling, and I probably would be quiet as well at this moment. So let's keep going, and let us hand things over at this slide. And so I can continue sharing my screen, unless, Philip, if you want to share your screen so you can click through, that's fine. Otherwise,
yeah, I think if it's okay with you, yeah, let me share my screen so I can sort of run the timing on my side here.
Okay.
Famous last words. I'm going to go to screen one. Let's see. I'm going to hit present.
Great.
Probably run at the same issues you have there. Okay. So we're sort of moving. I'm sort of just doing a setup here for the technology demonstrations. If you think about the diagram we showed, again, we keep making the point that the Open Knowledge Network is the combination of user peoples that are the community of the Open Knowledge Network, and then the technology and the information that it supports and makes accessible to everyone. So it's you're not going to see any details there, but the idea is that underneath all of the ideas of concept, we talk about human values, we talk about knowledge, resources. These are all encoded in this thing called knowledge graphs that are very trendy at the moment. And the only thing you really need to know about knowledge graph is that it has some sort of schema that says, okay, what are things in the knowledge graph? So a person would be a perfect example of a class. And then you have lots of examples of persons, Philip Murphy, Sonu Hashizaki. And so those examples or instances get added to the knowledge graph as each node is one of those examples. And so you build an ever larger piece. The part you're seeing here is simply from the first 10 interviews from the water quality group. You can already see there's a very complex graph of things and connections starting to happen. But beyond that, too, it's worth noting that we are very excited about how expressive this approach to knowledge graphs are, where basically all you need to do is capture A is related to B, and what is that relationship. And over the years, people have shown that you can capture a tremendous amount of the way that we think about the world and represent the world in that. But there's still going to be lots of traditional documents and images and so forth that will not be in the knowledge graph, but the knowledge graph will have access to them. So that's just a general setup. Our open knowledge network, supported by underneath of this growing knowledge graph, just as Google has a knowledge graph and Wikipedia has a knowledge graph underneath it, and we will connect to those as well. But so this sort of sets up the conversation a little bit. The schema, like I said, it's just a, in our case, this is everything that we're doing, as John said, is in motion. So this was probably accurate a week ago as to the core things we were modeling before we moved into knowledge domains themselves, people, organizations, regions, etc. And we lay out exactly what information we want to gather about them and how a person relates to a project they could participate in or they could direct. So this tells us what are the list of things that can be in there and how do they relate to each other. And then the knowledge graph itself, as I said, this was drawn from all of the interviews that we did, people working on the SAIL-SC model, and reports that come out of the SAIL-SC model, etc. So all of that was linked out of the interviews and goes into a growing, large knowledge graph that's full of nodes and connections. And how we then, when we looked at all the use cases and all the need-to-know questions that came across, we tried to then categorize from that, anticipating how we see people using this open knowledge network. And we have sort of, for the moment, broken into 3 groups of activities that you might find yourself doing. These may well change in the next week or so. We have lots of arguments with ourselves about what's the best way to group them. But I think exploring and learning makes perfect sense. If you imagine yourself on Wikipedia, you read one article, you start tracing links, you want to find deeper aspects of the situation, and you find yourself exploring and learning and exploring. On the other hand, of course, which these knowledge graphs do not appear magically. We have to develop, share, and maintain the information and knowledge within that. And so there's quite a few activities around that. I'm sure all of us at some point have made at least one contribution to Wikipedia when it hits on some subject we really feel strongly about. But on most of them, most of us are explorers and knowledge learners, and then and then we contribute where we can, where we think it's interesting. What we're hoping to do with this focused open knowledge network, starting with our 3, fire, water, and biodiversity, is to make it even more attractive for people to put information in, because you'll get deeper information out of it than you might from Wikipedia or other current sources. And then, because we are the Spatial Decision Support Open Knowledge Network, we of course have a great interest in leveraging all of that information that is in the knowledge graphs to support every aspect of people engaging in decision processes around actions that may change our world, hopefully for the better. Getting back to John's idea that we want to make changes. Just to give some ideas of the type of, what are these activity sets uses? So if you're in terms of exploring and learning, you have lots of questions like where, who, how, when, and all combinations of those type of questions. Who are the people who are doing research on sediment flow in the Snohomish Basin, for instance? And then show me instances of X that occur in region Y, the spatial side. How do you decide between A and B? What concepts are related to this concept? So I won't read all of these, but the point is you can see there's a different nature of questions for each of those. So different nature activities. When it comes to actually obviously growing the knowledge graph, we need to add new ideas, new concepts, new classes, new examples of those concepts. And we'll show some examples of that. And then when it gets to engaging in decision processes, there are many questions that I think everybody on this call have been involved in for a long time. Where's the best place to put Y? If I have an action I'm thinking about that it might improve indicator A at this point in this place, what happens to values of other indicators next door to it? And how do those previous answers vary under different future scenarios driven by growth and climate? So there, in these cluster of activity sets, there are, from the use cases, we saw many different actions that would, activities that you would be doing while interacting with the system. And supporting that, then obviously the system itself has to have a whole bunch of very specialized capabilities that allow it to support those uses. So obviously, the whole point about sorry about the KG to fill out the knowledge graph is inference. Is that we can run inference queries down those knowledge graphs, and we'll show some examples of those in a moment or two. And we want to be able to run spatial queries and spatial inferencing. When it comes to developing it, we need to have the ability, as anybody who's edited, who's tried to put something in Wikipedia, it's definitely adding information into a structured knowledge graph system. We could improve how that's done, and that's one of the things that we're working on. We'll demonstrate our early steps on that. And in terms of all of the things that really get me excited about engaging in decision processes, our SDS ontology that we built 10 years ago is inside the knowledge graph, or assumably, and it documents all aspects of spatial decision support systems, what's in them, the workflows, what models they use, what steps are associated with a particular workflow, how that workflow could be stood up, what's relevant towards, how it might be applied. And so being able to, that means then if we have some co-traveling existing spatial decision support platforms, and we do, we have at least two represented. One is the ENDS that many of us have been working on for years. That's the ecosystem management decision support system that started with Pete Reynolds in the Forest Service many years ago. And then John and the CBI are working on a system called EAMS, which you'll see more of in a second. So these systems we are trying to arrange in such a way that you'll be able to stand those. If you want to design a spatial decision support system to answer a particular problem, we'll be able to stand those up much more quickly and efficiently and less extensively by drawing and being able to actually use lots of the information that is in the knowledge graphs, and we'll give you some ideas how we think that'll work. So the demos are divided into three. There's exploring and learning demos to support that, and then there's some demos around engaging the decision process, and finally, how are we going to grow this thing? And so we'll get to that. So the very first is about editing and browsing the knowledge graph, and I'm hoping that Steve Papolinas is available to run his demo. I'm going to stop sharing. Steve, are you out there?
I think he's on mute. He's getting off mute in a minute.
Yes, I'm here.
Great.
Okay. Would you like to share your screen and show us literally, well, the latest up to the last 10 minutes version of the editor?
Give me 1 second.
Yeah, while he's doing that, I'll point out to people on the call, we're also going to show you another way, which is editing the knowledge graph, which is just using spreadsheets as well. So
yeah, I have a couple of slides on that as we go along.
So you'll have options on how to edit the knowledge graph.
And if you think about it, what we're trying to develop is essentially sort of merging. Google has the way they use a search engine, Wikipedia, the way that one builds articles and connects articles to other articles, and the spatial aspect, Google Maps. We're essentially trying to create something where you can move ever more seamlessly between maps, between knowledge graphs and queries against knowledge graphs, and articles and deeper artifacts that help us understand the world out there.
And also, Philip, while Steve is doing that, can you take a look at our agenda document? I want to make sure we have the new timestamps for this demo section. So I'm putting those in there right now, just to, I'm wondering if we actually do have 10 different sub-demos. All right.
Some are much shorter than others.
Okay.
Right. Yeah. Okay, Steve, just could you show us, roughly how you will walk around a little bit between the classes that we have in there and some of the instances?
Okay. Okay. So you can see my screen, everyone?
Yes, we can.
Okay. So what I'm working on right now, that we have 2 data sources inside the system right now: the SDS OKN ontology and the consortium ontology. We can go in and we can look at the individual things, so like job title, policies, scientist. And you can view the properties over here. And then
are you able to perhaps look at the people class, person class?
Okay, so reset's not working. So let's see.
So you can see already, and this is technology that's literally coming outdoors as we speak, is that we're trying to actually make it so that in Wikipedia, you can't actually move around the graph and move visually through the things that are connected to each other. You sort of have to follow the hyperlinks that you're given. And so we're trying, so the part of the concept here is that you can, yeah, go ahead. All right.
So I'm working on, I was just trying to work on the reset button to reset the view so you could go back and forth.
So these are all examples of persons, yeah.
On the actual person, so these are all the properties that make up J. So as I said, so if we look at person in general, then we can, let's say, look at Derek Day specifically and go through both. I'm working on getting, as I said, the reset view to work properly, but that should be done shortly. But you can either click here to look at properties, or you can look by class and by person. The next thing I'm working at is to actually allow you to like double click on here to update over here. So that's our next task.
Right.
And then,
so great. Yeah.
This was, I was working on the queries right now for this. Unfortunately, I don't have the loop completed, but this is it going off to saying, okay, the user asked the question, who's working at WA Ecology, and then it went out and it looked at the instances to look for Derek, and got a list of all the people, and then it filtered against the property work at as one word, and then compared against WA Ecology. And it came back with, I think, 6 or 7 people. But you have a for loop that will actually display everyone who was, let's say, working at a location.
Great. Yeah, just so Derek doesn't think we're picking on him. Yes, there are a number of people from Washington College that are in here. Yeah.
So the idea is that you'll be able to ask questions. It will go through the ontology main work. Just get information directly from the ontology. It may load data sets and do processing and build a map. And all these are dockable windows, so if you don't want to see something, you can always close it.
Okay.
Even these are dockable.
Yep. And also, just so everybody's clear, even though it says this is a desktop client, we have a server version, so everybody will be able to be doing this in their browser.
Right. This one is talking to a central server properly now, but yes, we are going to be porting this to the web. So
okay, great. Yeah. All right, thanks, Steve. And Steve, we told Steve that we want you to solve the problem that apparently Google and Wikipedia haven't yet, and you've got basically 2 months to do it. So he has been pretty busy. I'm going to share the screen again, and we're going to keep moving along these lines. We want to make it so that at the moment the trajectory to get information in is quite manual, and since I've been doing a lot of that, I'm really looking forward to this new interface working and starting to use it. Yeah. What's that? Okay. All right. So and then Steve had started to look at the type of queries we can run on this. Some of these are in here already. who's working in ecology, who's working on a particular model that would return a couple of people at the moment. And again, all of this is information that we gather from the interviews. And if we can get the system working well and you get excited about it and start helping us put in when you have interesting insights. Why are we focusing on people and projects and data sets at the moment? Well, because that's common. It's a common pathway into all of our different efforts, whether you're working on fire, water, or biodiversity. All of us are pulling together, trying to understand the network of connections and projects and work that's being done out there. And being able, from many of the use cases that we got were people saying, how do I find people who have some expertise and are working in a certain area? And so that's where we started on before we start trying to delve into the very particular domain-specific elements of each of our use cases. I'm going to just move on from that. So moving now into a slightly deeper part, which again is how we're going to leverage, how we are excited about, because we think we can leverage this growing network in ways that will answer many of the use cases that were posed by you when we were talking to you. I'm going to jump into the first one, and I'm going to go rather quickly here. You know, all around the world, when it comes to conservation project design, people have been using these things called results chains basically you have some sort of a target to maybe make conserve a forest, and that would be measured by perhaps cutting the loss of forest down from some very large number down to maybe half that size. And to get there, you come up with all sorts of different, you have the there's a direct threat to that thing, which is illegal selective logging, and you build out a strategy that will try and create an intermediate result, that will create an intermediate result, that creates an intermediate result that will lessen this thing, which will then actually slow down whatever the decay in the forest acreage is. So they're called results chains because they were trying to be very practical. Don't just sit there and say we want to magically get the right-hand side to happen, but figure out the steps that you'd have to do and what success looks like at each stage of those steps. So they're called results chains. Initially, they started incredibly simply, and then they became more complex, and they became even more complex. But this is part of our point here that, I can go back, right? Yeah. So you're not meant to see the details here, but this is from the Puget Sound Partnership's efforts with their working groups to develop a large results chain for marine water quality. And this is work in progress right now, but basically detailing all the man-made impacts, how they're affecting all sorts of different processes, how those processes interact together to change, and I'm going to zip in a sec, to change what we're seeing and measuring out there on the ocean. And we're trying to bundle up those measurements into indicators that will help us understand what is the current situation and what are the trends. And I'm going to focus on one that actually John mentioned. But I just want to show that the type of things you find now in these diagrams have moved on from threats have become stressors. Often, in fact, up here we're trying to call them pressures, because one man's threat is another person's livelihood, and so we generally call them. And here they've gone to stressors. Stressors work on impact on stresses. In all of these, sorry, I realized I went too fast. One of the key things at the bottom here is that we're starting to really focus on more and more at every single step. In order to know whether I'm making a change, positive or negative, I need indicators. And the development of these indicators is a critical part of what the Puget Sound Partnership is focused on. So you see that the vital sign indicators, John showed you a beautiful dial that is, we have a set of high-level indicators that we believe will help us understand all aspects, the core aspects of what's happening in the sound, and how to calculate those and operationalize them as part of what these results chains are giving us. So in this case, just focusing in on a little part, we've had the index that John showed a little ago that showed by some basins of the Puget Sound. You can see that the water quality index has varied over the last 20 years, but the overall slope is unfortunately downwards. And so part of what we're looking at is taking results change and seeing what the models are to actually get that index, the marine water condition index. And then we can represent all of the aspects of that calculation, that little explanation of how to calculate the marine water condition index. And that can be, and those aspects can be directly represented in the knowledge graph. And then you can actually, what we want to do is show how we want to be able to build on those to automatically create spatial decision support systems based on those results chains that have been captured, carefully designed by the scientists here in the area. We don't have a working example of that, but many of us here were involved in the desert tortoise, where we use exactly the same sort of results chains, such as stresses, and there's some intermediate steps. We're not going into some details. This is actually online if you're interested. It's the Desert Tortoise Recovery Portal. This is all work with Steve and with the Fish and Wildlife Services Desert Tortoise Recovery Office that was done over a decade or so. The models are up there. You can click on different parts of the thing. It shows this is basically a piece of a very complex results chain that we then, the idea is these are all threats. They feed to stresses to population factors, to overall population risk. And in these cases, for every one of these threats, we have data layers, which you can get from the Data Explorer. You can drop down and look at different data layers that are there. Once you have those data layers, you can then actually run calculations on if you were on what the risk in any particular area. So you can go to the what we call the risk reporter. You can draw in some areas that you care about and then have the system calculate. So it's now running those computations down through those networks of threats and stresses and recalculating. And what you might see, hard to see here, but area 3 at the bottom is the yellowy thing here. It has almost no scores, whereas areas 1 and 2 have very high risk associated with them. Those big red blotches, what you're looking at there is basically landfills just out of Baker. So, and they are not friendly places for tortoises. So the main takeaway from this is that we are very excited that all of the great work being done in building out these result chains in the Puget Sound, that we, in phase 2, we could address some of the use cases that we have if we could then actually operationalize those results chains as parts of spatial support systems. Okay. Moving over to Mike and wildfire. I'm going to stop sharing and switch over to Mike.
Right. Let's see.
And also, while that's happening, Philip, how much time? So I think we're a little bit behind schedule. Originally, Mike had 7 minutes, I had 7 minutes, but we need to finish by 11:25. I'm wondering how much time you need for the last section here, of developing, sharing, and maintaining information and knowledge. You know, the data finder, the polar hub,
right,
semi-automation, and knowledge graph.
Well, the spreadsheet part is pretty fast, and likewise with the Q&A finder, and then Wenwen's, I'm hoping we're aiming for 5 minutes on that.
Okay.
All right, I'll try and time myself. Can you guys hear me?
Okay, so it sounds to me like, Philip, you're going to need 5 minutes. So that leaves 12 minutes for you and I, Mike. So let's each aim for 6.
6 each. All right, I will hustle through this. So feel free to ask questions later. So in the wildland fire case studies component of this project, we focused on a couple of main areas working up to the third. And so the kind of highest value adds we saw from the geosemantic web involved enabling the extraction of geo features from text queries and from text itself. And I'll show you an example of that. And then from finding new ways to make it easier to publish and consume time-varying spatial data. So there's some evolving OGC standards on this topic, and I'll show you an example of that. Those are all kind of core components towards the bigger vision for phase 2 to make alternative future scenarios and their core elements machine computable and easily distributable across the web. So what Phil was just showing you, just to give you guys background, all of us are kind of frustrated decision support system constructors from years back. So I wrote the original spec for Model Builder when I worked for Esri. And my big frustration with Model Builder was how little of the models that were made inside that tool were shared out in formats that other people could pick up and use. And so that was, in part because that was done before the internet had hit full force. But we think we can unearth not only the overarching big outside version of a model, but the granular details about assumptions and workflows and impact assessments that are really critical. So as an example of the first kind of issue area, a lot of essential information about fire incidents is locked up inside piles of PDFs. So the government likes after action reports. So we've got these for every major fire in the US. And these, in this example, come from the California Public Utilities Commission. They're every incident of stuff hitting power lines. But it literally is a pile of PDFs. You look inside the PDF, you see an email. Oh, great. And then you look at the bottom of the email, there's an incident location with an approximate geography. So what we want to get to and have in pilot example, I don't think I have time to show live, but is a dashboard where you can take that textual information, extract it out spatially, categorize it visually, in this case by the type of object hitting the line, and to realize that these are both spatial and temporal. So these in the upper right are the number of records by incident date time. And you can see there are temporal patterns. Obviously, it's seasonal stuff going on, as well as categorical. So we want to reconnect textual information with spatial information, and do that at scale. The second example is something that I originally did for a major Northern California utility, and we're generalizing out. So that is connecting weekly satellite data already referenced from European Space Agency into an indicator, in this case, the vegetation dryness by power line span. So utilities manage their networks in these line spans, and they need to have information about what are the priorities. And they've previously done that with field crews, but we all know the results have not been great. So they need to have a synoptic way to look and get near current information on vegetation dryness, for instance, in this case. And the third aspect is this linkage between geographic and semantic webs. And we mentioned this earlier in the slides and the challenges. So you all are familiar with GIS systems. Those are based on relational databases. And the semantic web is based, as we've seen, on graph networks. So a big research question of very large practical importance is, can we build efficient bidirectional linkages so that we can avoid replicating data? And of course, in the world of the web, you do that with requests and responses so that you don't need to keep two copies of all the world's data, one semantic and the other geographic. And so as an interesting anecdote, I found this particular method from biblical historians. So believe it or not, there's a group of high-tech biblical historians that had the problem that they needed to deal with places whose names change over time. And so they came up with an extension of an OGC standard for geospatial information transfer called GeoJSON, and added a temporal component. So this is a normal GeoJSON file, except it has a when clause. And the when clause has time spans and periods and labels and durations. So not to get into too much detail, but there are starting to be interoperable ways of talking about time varying phenomena. And obviously for fire, we have a bunch of questions where we want near current information, or we want to be able to replicate historic events that occurred through time. So that's all I had to run it quickly, but I can show any of you this live later that are interested. Thanks.
Great. Thanks, Mike. So one of the things we heard quite often among our groups and is this question of how do we make the spatial decision support open knowledge network more transparent, and how can we communicate the workflow better? How can we co-produce the workflow? And so one of the things that we've looked into a lot is this idea of a workflow editor, workflow browser. And so here's a screen grab of the where things are going. Over here on the left, you'll be able to click on workflow editor, workflow monitor. And in fact, Steve, can I give you a minute at the end of my time just for you to show us where that stands, or should I just roll through this?
文波的你的任务跑在我们自己的机器上了。
You guys take right now, just continue on.
Okay. So you'll have that opportunity during the discussion period maybe to show that. And so what we're doing is we've already built in the language of MPilot, which is it's a Python implemented library of tools into our whole stack. And MPilot has a really strong interface with EAMS. And so what we're going to do is blend the two. So we're going to basically have this stack that includes EAMS online functionalities. And so as part of my 7 minutes, I'll just show an illustration of this. So EAMS Online is created by CBI, by Tim Sheehan, Mike Goff, Jim Stritholt. It actually is a spin-off of EMDS, Ecosystem Management Decision Support. 12 years ago, we had a client that was really wanted to hire us. We wanted to do EMDS, but they wouldn't let us because of the software constraints. So we called up Keith Reynolds, who's also on the call, the developer of EMDS, and Keith walked us through the details of it, and so we were able to replicate this aspect of EMDS. EMDS has so many more aspects than the logic model. So here we have the working forest lands of the Cascades to coast. So the question is, where on the landscape are there really important working lands to conserve to make sure that they don't get paved over? These are areas that can provide biodiversity value, but also natural resource extraction value as co-benefits. And so here's the model. The areas in red are the highest priority areas for that. Then you can ask, well, why? What went into it? You can click on any one of the criteria boxes within it and be able to see the map of that. So this is spatial decision support, and see some of the sub-criteria. Okay, so now we see, there's the working lands criteria, but what went into that? Well, here's where timber harvest is high, so areas in red. So that kind of drives the model. Areas where there's high ecological importance, that also drives the model. What went into high ecological importance? So it's very transparent. You can see what's going on. You can also click on the gearbox and be able to change the operators, change how things are combined, or change the weights if there's a weighted union, and go ahead and rerun the model, see what that looks like, save that link of a new model, share it with people. So it's public participation GIS in the web browser linked to the Open Knowledge Network. So it's kind of that continuum of spatial decision support I mentioned in one of those earlier slides. And so what we're going to be doing is be able to have the workflow editor in the browser space. And so you can actually, it's kind of like Model Builder. You can have different commands linked together, and you can detail what the output and input is in a Windows-based thing. So you don't need to be a programmer to create those workflows and then to share them and share them with people. And then also, of course, the intelligence engine is going to be able to find them and share them and use them as well. And so here's a wireframe of what that could look like. You've asked, who is Sean Gordon? It's given you your answer. You ask, well, what's the effect of fires on plant life along the Pacific coast? Submit it. It can actually go in. If an EAMS model was already made for it, it can go ahead and pull that out and give you results. And then, well, how was the result generated? And it can actually give you the summary of the workflow. I'm imagining we can also link to the workflow. And if you want to export the map, you press submit and you can tell it where to save. And so that is the real quick skinny of what I wanted to show. So what we'll do is we'll bank my last couple of minutes for further in the discussion. And then Steve, if you want to show us what the workflow editor tab is looking like, you can. But if you've been really focused on the ontology browser in the last few days, I totally understand, and we can skip over that. So let me pass things over to back to Philip. All right.
Okay, great. Can people hear me? I have some interesting.
Yes.
Am I? Yes. Okay. Thanks. Great. So yes, we're right here. We're wrapping up. I know this is we've flung you through a large amount of. How do I move this thing out of the way? Probably can't.
All right. So at the bottom of Steve's editor, there's a little button that says, which I hit around here, which says generate an instance.
It's not sharing the screen yet.
Oh, it's not sharing the screen. Okay. Thank you very much.
There we go.
All right. Okay, so at the bottom of the screen here, Steve has a button on his editor, which is now included, which basically says create a template for this particular class that he happens to be looking at. So if he's looking at the person class, it'll generate an Excel spreadsheet. And in fact, these Excel spreadsheets exist right now. One of the ones I've been using to put stuff in there, so that and they basically they will tell you that there needs to be an identifier, and then it tells you the various fields. Which can be regions, does it have a name, does it have a URL? You fill those in, you don't have to fill them all in, as long as it has an identifier, we're okay. And then once you fill those in, at the moment you can submit them back to us and we could manually pop them in, but soon with Steve's editor, you'll be able to actually simply import that spreadsheet back into it. So this is very exciting because all of us are working with groups, we all have information in our back pockets, and this is a way that we can jumpstart the expansion of the knowledge graph through table spreadsheets. And I think John already has groups of people ready to go on that. But there's the real excitement here, and we're only really starting to scratch the surface of this as we're proceeding through here, is auto-finding new relationships and new ideas. This is a really interesting tool called Question and Answer from the New Jersey team, New Jersey Institute of Technology. And in that, you can go online and click on this. You can choose what is going on here is that it is looking at all of the need-to-know questions. There's about 1,200 from the UCGIS group and about 300 or so from water quality and more from fire and biodiversity. All of these are text questions, and there's a whole new set of AI technologies that they're revolving around being better able to understand whether two chunks of text really are representing the same thing, have they read the same meaning behind them, regardless of the exact words that are inside them. And so they have, you can play with this yourselves. When they run all of these through, it auto-classifies them and starts saying, well, these things are all very similar. If I were to click on those, in fact, this class is actually water. I looked at the examples they have there, and they all look pretty much part of water quality, particular contamination. Other ones of these groups, so they basically classified all of those, about 1,500 chunks of text, and grouped them together. Some are very far apart. These are very GIS technical stuff, far away from the actual domain area like water quality. And so you can start to see new relationships and new ways of thinking about this, and we can start building new classes. And even better if you play with these guys, with the tools they put together, is that if you click on any point on this thing, it will actually then, they have pulled more than 30,000, the abstracts, more than 30,000 research papers out there, and it will then match the meaning of that particular chunk of text to what they see as similar meanings that they're finding in the abstracts. And you can scroll through these, it's all there and online, and see what's there. And there's still a human in the loop, because just like in Google, in the early days of Google,
how do I restore a connection to Wi-Fi?
Say it again, please. Sorry, was that a question?
I think that was just a mistake.
Hello?
Keep going. I think that was a mistake. He didn't realize he was on mute, is my guess.
Oh, okay, sorry. Okay, sorry. So, and then there still is a human in the loop here, because just like with Google, when you get search results, you don't click on all the links. You click on the one you think is most actually relevant. And in fact, there's a little relevance down here that you can drop this down and say, give it a 4 if you think, yeah, this is totally on. So, and if you do some of that then their system actually will learn from how you've reacted to the things they've shown you. And just like with Google, we can get better and better search going forward. So this is just one aspect of what these guys could do, but you can see how this could start to help us snowball forward the development of new classes and new ways of thinking about all this information we're putting together. And then the final demo is from Arizona State University, and I'm going to stop sharing and hope that she's able to share her screen and show us in 5 minutes how Polar Hub can help us actually find new data sets, so that we don't have to manually put them up there, but in fact, if you give it enough instruction, they can go their system is actually out there as we speak, crawling the web, finding data sets. Are we, Shizay, are you on? Can you get off mute? There we go.
There we go.
Right. Not hearing any sound at the moment. Can you perhaps, there you go, there you go.
Okay. I'm going to demonstrate. Okay. PolHub is a cyber infrastructure portal developed by issue led by Dr. Wenwen Li. We built it to collect a geospatial data set that's scattered all over the internet. PolHub provides a one-stop data discovering experience instead of looking up and downloading data in many data providers. Currently in PolHub, we focus on collecting geospatial data that are publishing OGC standardized web services, such as Web Map Service and Web Feature Service. So far, PolHub discovered about 150,000 services. You can see this photo visualizes those data services in this virtual globe. And each bubble represents a data provider. The number indicates the amount of service it provides. And we can filter all the services by service type and country that publishes the data set, as well as the categories that categorize the data set using a scientific ontology. We select the data service in the United States and click a bubble in the globe. It expands all the service in the data provider. Each color represents different service type. We select one service, then some basic information shows in the right side. It also provides a link to the metadata of the service. And also we can expose the data in this service using GCI, a spatial data visualization and the analytics tool that's developed by us. I will briefly demonstrate it later. PolHub provides the capability of collecting more data service by creating web crawling tasks using related keywords. It can also collect data in some specific organizations such as USGS. Here we select and check a finished task, and we can check its information and some statistics of discovered service by service type and the service provider country. To view and utilize the data we collect, PolHub provides a search function to find desired geospatial data by keywords. Each data service can contain one or more data layers, and more than 1.6 million data layers have been indexed in PolHub currently. For example, we want to find some data about watershed in Pacific Northwest. We search watershed boundary and got about 3,000 layers. Similarly, we can filter our search results. We select Web Map Service for fast investigation purpose. And did publish in the United States. And here's the data provider states, Oregon State, which relate to our study area, and we also select it. We can view the metadata of each search result, such as title and description, abstract, and keywords and the bounding box. And here's the thumbnail for the data layer. We can click it to preview it on base map. We can also load this layer in GCI to perform more complex visualization and analysis by this link. We also search what temperature and the dissolved oxygen data using PolHub and loaded them all together in GCI. And here's a visualization in GCI. The toolbox in the left shows the loaded data layer and corresponding legends. Here we hide the web temperature layer to show oxygen concentration layer more clear. And that's it. Thank you.
Hey, thanks very much. That's excellent. And obviously where we're going with this is that we want to make it seamless so that as you search, if you put a search, you're saying, show me, can you give me dissolved oxygen layers within the Hood Canal, that query runs down to the open knowledge, to our open knowledge network and queries their system so that you would see some of that coming back to you automatically from all the data sets they found. And if you ask a question that they don't have data sets for, we want to set up a mechanism by which they can then start a search crawl of the internet to find such data sets. Okay, that's the end of the demonstration. Thanks for your patience through all of that. So, give it back to John here.
Okay, fantastic. So yes, that is exciting. One of the exciting things about this project is every time that we have a presentation, not only are we presenting for the collaborators on the call, but for each other. So it's one of the ways we all get together to be able to show some of the things that we've been working on. And it's really great to see things coming together. So we've got just really one more slide essentially that we could cover after our discussion, but just to, I'm feeling like it might be good to just throw it out here right now so we don't have to come back to it. It might answer some questions. And so the discussion is wide ranging, both feedback on the presentation, on comments on how to make it better, but also on just the whole overall project. Also, I mentioned that we would have potential next steps, and one is for any person on the call to co-develop a phase 2 proposal collaboration with us. If you're interested, to talk with your team leader. And for now, what we're doing is we're only focusing on in-kind support. So in other words, collaboration in which we're providing all these resources and technologies, and you would be coming to it as either a beta tester or a partner, it's the win-wins. We're looking for those win-win situations. We've got the national workshop online coming up March 4th from 10 a.m. to 1 Pacific. You're all invited on that. More details are forthcoming if you haven't already received some information. I know I still need to send out my invites. And we're working towards an NSF-style letter of collaboration that we can put in our proposal. It's essentially just a one sentence saying, yeah, I want to collaborate on this project as per the details in the appendix and or the text of the proposal. And so that's where we would actually detail what is the collaboration itself. And I think that's everything. We've got some draft goals for phase 2 if people are interested, but really I think it's time to jump into the discussion. So thanks everybody for your attention. I know that there was a lot, a big hour and 25 minutes of a lot. So thank you with that. And I forgot to mention at the beginning that we are planning on sharing the slides via PDF with you. So if your team leader doesn't already have your email, or if you've joined the call since when we did introductions, please email your team leader. And great, so now let's go ahead and have discussion and thoughts and questions.
And John, there's already a really good question right there on the right-hand side in the chat that hits on a bunch of really important things like who owns the information and how it will be used, etc.
Okay, great. Why don't we just we'll start with that while everybody's thinking about their questions. Unlike when we do this virtually, we have no idea how many people are wanting to raise their hand and talk. So let's assume that there's going to be some more discussion as well besides what's started in the chat, because I know we could spend the entire remaining 27 minutes focusing solely on the really important issues raised in the chat, but I know that there's going to be also real-time comments. So the first one is at 10:53 a.m. from Phoebe. Hopefully she's still here. I most probably leave for shortly before 12, so just in case, I'm going to hit my question on technology and wisdom. We all know that the human race, especially in the global north and west, has more knowledge technology than wisdom. we have all this technology energy on the left side of the continuum, but how can we really match this universe through the OKN with the rapidly changing ethical, moral, spiritual universe of an angry and impatient public in order to learn lessons, use evidence, and do things better in the future? That is a fantastic question, Phoebe. Thank you. I think even before we get into it all, I feel like there are several. I think we should answer the question and also keep in mind the context in the fact that we're applying to the NSF, which really prides itself on science and engineering, and in a program that's really focused on that. And so this is one of those great things where partnerships come in really, really powerful. So if there is a partner really wanting to take the lead on that question, we can enable it by putting it into the proposal as a key question. I'm not saying that to dismiss it at all, by any means, but that's just my initial thought on it as far as just being facilitator. But I think we should also give a chance for the other panelists to answer that, as well as anybody else on the phone that wants to chime in on that before we get to the next one, which is from Carl Palmer.
John, can I jump in?
Yeah.
So yeah, from my perspective, well, first on the ownership issue, the knowledge network, so far as, you know, the open part of the open knowledge network is that this is all knowledge that people are willing to share.
Oh, so Mike, I haven't introduced that question yet. I think
I'm sorry, I'm jumping ahead. All right.
Okay.
So relative to Phoebe's question, you know, absolutely, that's a well-known problem. And what we're focusing on is on increasing access to what have been heavily professionalized and vertically siloed tools. And so our hope is that with all of this wonderful new visualization and communication technology, we can engage people interactively. And if they see the results on their own and are able to explore them and engage with them, we think that can help us towards the right side of that flow. I was going to show a live visual if I could share my screen.
Yeah, absolutely.
Let's see. I'll just go with desktop. So, you know, I referenced really briefly in my talk, but there is this huge world of big data out there, starting with satellite data. It requires a bunch of work to clean up into forms that are analysis ready. But once it's analysis ready, I think it's pretty accessible. So here's an example of a startup I'm involved with called Tesselo. And it's this is mapping the transmission lines of California again, but relative to a foliar moisture index. And so what this component is doing is taking thousands of satellite images and mosaicing them, the cloud-free portions of them, and pumping out an index. So that's kind of one step in the chain. Here's another example. Some of you are familiar with Google Earth Engine. So that's doing similar work, although the interface here is a programming language, a JavaScript library. But here is nitrogen dioxide concentrations for the planet. It's basically daily time step data. And oops, really wanted to show you some of this because we talked about it as well. So the massiveness of these data systems, the data is one issue, but our ability to visualize it with cloud-based mapping is a really important component as well. Yeah, I talked about that example. Oops, timing up. Sorry. So anyway, to kind of get back to the question, we know from education that engagement with data is really important. And so the more opportunities we can give people to engage interactively with these data sets, the better off we are pushing towards the right of the curve. And I'll leave the far right for others to comment on, but I think the development of knowledge certainly starts with trustworthy data sets and visualizations that are interoperable. It doesn't get us all the way to the right, but you know, we can talk about some of that in the other questions.
Great. Thanks, Mike. Good. So, oh,
that finally came through. I'll show you wanted to show one other data set that I think is significant. So I mentioned, let me get the Zoom thing out of the way. So I mentioned that private data sets are coming on strong. So here's a really interesting data set that I think is relevant in different contexts for a lot of you. So in red are the OpenStreetMap data for roads in North Korea. But in yellow to blue are a new data set that's created from machine learning by Planet Labs. And they make a once monthly global road map. So you heard it right, every road in the world remapped monthly. So in this example, you could get a sense of the level of detail available in these data sets, and I'm not showing the underlying imagery, but we have to think about a world in which we've got machine learning taking the inputs from raw satellite data and creating, for instance, in this case, vector feature data that is continuously updated. So whatever our systems are that we put on top of this, we need to kind of think of data flow going through them, where the old habit of GIS being static and constant has to go away. We have to come up with ways of continuously feeding live data into these systems, and that makes them more compelling and actionable, I think, from an educational point of view as well. So anyway, sorry for the jump back and forth there.
No apologies necessary. That was fantastic. Thank you. So great. And so as a point of process, I think what we'll do is I have some the questions so far on screen here, and then if anybody else has a question, just in the chat, just say, yeah, I have a question. You don't even have to say what it is, just so we know how many more we have. And then we'll try and we're going to leave the last 3 or 4 minutes of the hour for wrap up. So in response to Phoebe's question, Paul wrote, knowledge reveals opportunities. Will they be used for private gain or public good? It depends on who has power. We might be able to minimize maluse by ensuring universal public access, really similar to what Mike was just saying. People learn most in school. How can we enable schools to access this information source? So Mike or Philip or even Sean or Tim, anybody want to briefly answer that? Besides the same answer I said before, which is, this is a great opportunity for partnering with someone who wants to take the lead on that, and then we can enable it by partnering and providing the support to the beta tester of the tool access.
Yeah, no, I do think I'll extend a little bit what I mentioned before about Model Builder. I've spent many years in academia teaching generations of students GIS, and if they got through my course, they created Model Builder models. And so I think that there's a body of knowledge out there about how to combine geographic data sets into models. However, that's still a very elite activity. And so it really is important that more people be able to construct model-based actions and responses. And this is a little further than we've gotten in phase 1, but this is the reason why we're planning ahead for scenario and impact assessment and workflow support, because we think it's really important that a larger community have access to those tools, and for instance can grab a workflow that one of us generated and change an assumption or question an assumption, right? So if we had the ability to talk about interventions or policy changes using geographic data, that requires us to, of course, have access to the data, but it has to be better than read-only, right? We have to have tools that let us recombine and adjust and repropose. And so that's why the team is so engaged on those aspects. It's kind of how do you mash up the data that you have access to? Power always has something to say on this topic, but right now, most of this data is already publicly accessible, I would say, with the exception of the Planet Lab stuff I just showed you, but a lot of this data is publicly accessible. The problem isn't so much the access to raw information, it's the access to high-level synthesis tools. I guess I would end by noting, what's the difference between what John was showing us with MPilot and what Model Builder did 20 years ago? it's a much higher level tool. So in Model Builder, those of you who have used it, it's kind of a bottom-up tool, and you're combining primitive GIS operations. What John was showing is kind of the inverse, that you're starting with high-level concepts, or Phil also showed this, indicators or other high-level goals and concepts, and working your way backwards. And so that's, I think, a much more shareable version of these things, because we all understand the high-level concepts, and then we have a kind of level of depth, each of us different, of how much you or I understand about dissolved oxygen and its effect on salmon. But we need to have ways of communicating this stuff with a high-level representations, but that still remain connected to the low-level stuff underneath. But there's been a real shift in doing stuff from a technical basis and then building up to decision, which was kind of the first 20 years of a lot of this stuff, because we had to build it that way. But now we have an opportunity to work from these higher level concepts and to be able to share high level concepts. That's quite new. I'm hoping that will help us to take water quality models from Puget Sound and apply them to Lake Tahoe, for instance, right? Like why is that currently so hard if you unpack it? There's a lot of reasons, but certainly in terms of the access to data sets, I think that's less and less of an issue, except, as I mentioned, that the data deluge part of it becomes an issue. But
yeah, this is Sonal. Can I also make a response here?
Please.
Because I'm not at all a technological GIS person, but I really think that that Phoebe's question and Paul's questions really come together. From a kind of a high level conceptual look at it, we have, as Mike was just saying, we had like all this a deluge of static information. And then we had the issues of people kind of knowing about where they live and how they can understand it. And I feel like the application of the decision support capabilities to this data and making it more interactive, and it enlarges the relational space. So it enlarges the space where people can find each other and explore together. And what emerges out of this wide area of exploration, I think it's one of the better ways for humans to encounter the complexity and the uncertainty of kind of the time that we're in. So that what should emerge out of the opportunity of the AI applied to kind of our human sort of immediate needs is this wider space. It's a little more spacious, in which kind of new insights can emerge, and in which deeper understandings by the people who come to this space all come away with. And I think that would actually start to shift the way our institutions and the larger social frameworks operate.
Mm-hmm. Great.
So let me just add a little. This is Tim Nyergis. I know Paul Williams is interested in primary education. So Mike was mentioning about higher education, but along the lines with what Sona was just saying, in primary education, as well now is adopted in the lower levels of higher education, the question and answering genre, which is out there now. And Sona was mentioning that the relational aspect here, we're really talking about information neighborhoods and knowledge neighborhoods now in an informational space. So we're not really talking just about the nature of the physical space out there. And that's really what the qualities of a knowledge graph are. They provide us relational qualities to the neighborhoods of these different things that we know. And with the co-production of knowledge, co-production of information, which is growing, that sense of collaboration with the world has not focused a lot on, but has growing focus in the last 2 decades, at least in the educational realm. The nature of the activity sets that Philip was talking about, it's this learning and exploration, which also has the querying part in it, connecting together with what the New Jersey Institute of Technology was has been exploring in terms of these categories here. How do people form new categories of ideas out of the data that we have? So it's a much lighter lift, even though the artificial intelligence and machine learning is more technical in nature. The nature of access to this information will expand more readily, because it takes more sophistication to build simpler systems, as it turns out. It seems ironic, but that's just the nature of the way technology has been evolving over the last several decades.
Great, thanks, Tim. So let's get on to another couple of really great questions. These come from Carl Palmer from Legacy Works down in Santa Barbara. So Carl says, I'm quite curious about the questions above, and as we looked at the results change examples, I was struck by the fact that we're seeing mostly biophysical data and not the social side. The capacity, know-how, power dynamics, connections, relationships, and trust, or lack thereof, among people and organizations and agencies and funders that we find in our community-based work are the biggest determinants of the success or failure of impact efforts that are built on top of the biophysical data that's needed for decision support. So how is OKN looking at assessing and tracking change over time in these key arenas?
Can I jump in on that one to start?
Yes.
So I think of this in the geodesign framework. And so in that framework, for those of you who are familiar, the first step is representation. And so we're really working right now with our partners on that representation piece. And so that's why it's important that we have people, places, organizations in the representation. But the other phases of geodesign process build on that. And so, for instance, there are process models and change models. They require a representation in order to have something to compute on or to talk about. And so our expectation in phase 2 is that indeed we build on those to use the people, places, side of the knowledge graphs that we're showing you. We don't have those in yet in a, we have them in pilot mode, but we don't have enough real data in there yet. And we had a lot of kinks to work out to make that part feasible for outside collaborators to help us construct. But once that representation piece is in place, then indeed, I think that one of the ideas actually from Santa Barbara was, what if we look at before and after network diagrams of the people and institutions that we've engaged with throughout the course of a project or an initiative. And maybe we can judge our effectiveness or lack thereof by looking at the difference in the network diagrams before and after. I thought that was a wonderful idea. You need the basic representation, obviously, to do it, but then that would be applying a kind of change and evaluation of the change in the social network as an outcome. We're not quite there yet, but that's indeed the direction. We wouldn't bother with representing all of this stuff digitally if we didn't think we could add process, impact, change models on top of that. But we need to figure out the core representation first before we can kind of build that in the system.
And I think we are there as far as being able to build the social network diagram by populating the Excel spreadsheets now, and then being able to look at it later, be able to do that correlation. Maybe we're not there yet as far as automating the process models and change models, but I think that we're in line to be able to answer that question. Any other comments from the panel before we jump on to this really important question about data sovereignty?
There's just one issue there, John, and Carl, about reaching more broadly to the social. So I know the concern here as we focus on institutional connections here, but one of the things that has been suggested to the team is reaching more broadly into the population realm. That is, what is social population demographics out there in the world? And one of the ways that we're envisioning doing this is perhaps picking up more of the idea of land use and land cover change as people live in various places across the country. These communities of populations, they are all governed in a different way institutionally. So bringing in the issue of land use, land cover change together with population change is the way to speak directly to the nature of the threats and stressors that might be influencing biodiversity, water quality, wildland fire. So again, it's not directly a biophysical data set. Land use and land cover change are as much influenced by population characteristics as opposed to really when we say social characteristics, because social being the community-based interconnection among them. Nonetheless, that's a way that the group is thinking of moving forward without looking at lots of different kinds of social demographic-oriented applications, because we have tended to be focused more environmentally than, let's say, on crime or opioids or something like that.
The other thing I would just mention about that I find very exciting about the New Jersey work is that that's a first attempt at visualizing how people are thinking about important questions in this domain. And so right now it's everybody and it's sorted out by domain, but relative to this question, as we get more sophisticated, I find it really exciting that we can look at the kinds of questions that different communities are asking and the way that they're asking them. And we can do that through common language. We don't need to teach them a query language or teach them how to use GIS, right? So I think that's pretty important. If we're able to broaden that out, get communities engaged, and figure out which questions they're asking, then we can literally map that now. And so that's a very novel, I realize it's kind of deep conceptual demo, but I think there really is a lot of meat there in terms of being able to look at the kinds of questions people are asking in a disaggregate fashion, and then ultimately, obviously, to help build tools and workflows that answer those questions, and hopefully answer them then in a culturally and appropriate way given the questioner, right? So there's a lot of work to be done there, but the core is deeply embedded in this idea that we need to be able to go between text and speech and geographic concepts and concepts of people and communities. So we're building it up from the ground with duct tape and baling wire, as you've seen. But I think the pieces are starting to come there, and there really are importantly different pieces, because we never had that ability before.
Great, thanks, Mike. We have 2 more minutes until we break for our closing of 2 minutes, and so I think that we've got another really important question here. So for the sake of time, hopefully people have had a chance to read it. It's really about this question of data sovereignty and who owns it. And so I think that one of the things we've talked about in our, when the whole team met together in Portland last month, and we talked about this, the issues like this that are going to come up about, hey, if we're really going to be doing action research rather than your typical NSF research, which is just a desktop study, but it's not real world, we're going to need to figure out ways of answering these types of real world questions. So we've lumped this into the idea of governance and decision making. And so this is an open question on how we're going to be, how formalized we're going to be doing it in phase 2. If we're going to actually make a 501c3 organization centered around kind of the outward facing, or if we're going to partner with an agency that's really focused on the governance issues and some of the real world issues of actually coordinating with real world efforts and eventually scaling this up nationally. So that is a bigger picture question, and that's kind of open-ended. And as to this particular issue, we need to answer it right now as far as the individual case studies. And so as of now, we're going to do it on a case-by-case basis, I believe. But what I'm going to do is suggest this as an agenda item for our next team meeting. And there's going to be a few different proposals on the table, which may be a working group of the different efforts that are wanting to fill out instances, like the Santa Barbara team. I know there's folks in the Puget Sound as well, and to really address this question of finding the right balance between, the right, because data sovereignty is walking a tightrope of many, many different conflicting issues between privacy as well as openness, and it's essential we get that balance right. Any last comments on that before we get on to the agenda? It has to be a really quick comment. Sorry that took an extra minute.
Yeah, I would just say overall, I mean, I think we're all seeing this as a very distributed network, and we don't need to have a single answer to those questions. So we will work with the different partners to see what they need and want. We're seeing it as a very open network, and in terms of the ownership of intellectual property or data, you know, we don't have any particular desire to own this. We're trying to get the network to prosper and thrive. So
I just want to, this is Carl, I just want to clarify, I'm not so concerned about the ownership of the data. I'm concerned really, I mean, I think looking forward, this is a place where users, individual people will potentially have significant profile data. Almost, it's not Facebook, we're not obviously doing that, but the ability of an individual to have some sovereignty over their data and how it appears or doesn't appear, I think is really a critical consideration.
Okay, we did actually talk about that briefly, but yeah, we pushed that to phase 2 in the sense that traditionally the knowledge networks, yeah, they are open knowledge graphs, but what do you do if somebody wants to keep their phone number private or whatever, right? And the editing parts that Steve has been building do have some privacy and security pieces built into them, but they're a layer down, and so we haven't actually built out the kind of user interface tools for controlling that yet. But I think as Wikipedia has a way of doing this, like we will need to have a way of doing this, right? So we haven't entirely ignored the issue, but we've punted a little bit on it originally because we're hand populating this with public data to start. But there's also the thorny question of data in progress, right? And so, yeah, we know that we need to provide users different levels of access control over different types of information, some of which might be eventually public, but not public now, and so forth. So it is a subject of further discussion, but we're aware of the issues there, and there are many.
Mm-hmm. Great. Yeah, thanks, Carl. Thanks, Mike. All right, wonderful. Well, thanks everybody so much for coming. This has really been great. And I encourage you to follow up with us via email, also to expect follow-up from us via email. We're going to send out the slides. I'm imagining we're going to be sending out the phase 2 goals after our next team meeting, or the draft phase 2 goals. And we have a draft technical narrative that we're hoping to send out, as well as the Excel spreadsheets are coming soon. So this may be over the course of 4 emails, or it might be one big blast. And for those of you that were keeping notes on today's agenda, on today's meeting, I haven't really been keeping the best notes. If you want to send them to me, I can help combine them. That's mainly to the people on the team, but to everybody. And then the emails, feel free to contact any one of us on the call, and with any follow-up thoughts or questions, or just stay focused with your team lead if you're associated with a team lead. And Philip added a key question here for maybe you to ponder as on closing, and maybe it's a good excuse for us to get back to us with an email to help answer this question, which is, we've all been part of knowledge capture efforts, but most have stalled. Did what we show suggest to you that this effort might be sustainable? So that's one of our goals for phase 2, is to make this a sustainable effort, and along those lines also to cover all the possibilities and make things modular. And for instance, any work you do in populating the spreadsheets and populating the knowledge graph, we're going to be getting it back to you to be viewable in this viewer, but also in the actual machine readable format that you can then be able to upload into another viewer and things like that. So we're keeping in mind this idea of sustainability and practicality quite high on the levels of our minds. All right, let's see. I think that everybody is welcome to start dropping off. If you want to make a comment before you leave, that is fantastic. And thanks again, everybody, for coming. Thank you.
Thanks, everybody.
And in fact, I just wanted to make sure that everybody who had a hard stop at 12 could get off. I'm so jazzed up by that call. I'm going to be staying on. I imagine a few other people might stay on just to have further comments, conversation, both within the team and without. So thank you all. Give people a moment or two to drop off. I will actually even call out Sean. I'm interested in hearing some of your thoughts and feedback either now or later. Other people that were on the call, other people that didn't have a chance to chime in.
This is John Payne. Can I just make a quick comment?
Absolutely. Yeah, thanks for joining us today.
Yeah, thank you. It was really interesting. I thought the questions about social data were very interesting. And essentially, it seems that as you've got this project set up now, most of the social questions essentially are who is doing what, which is a fairly limited question. The result chains that you showed basically start at a policy decision. And I can see that there's a little bit more social richness potentially in the graph because there are questions like, or there's data like who has authority for something or who has jurisdiction. But it seems to me that that could be, and I also take Mike Flaxman's point that, you know, the first step is representation. And once you've got that, you can do a lot more, and that you're still working on the representation for these social questions. But it just seemed to me that you could you could increase the richness of the social part of your graph quite a lot by adding data like what resources does each organization have? Who works with whom? Who's influential in this graph? You know, that's a very standard question for social networks. Who's influential in the graph for a particular issue? And then starting towards essentially aiming at questions like where are political bottlenecks, modeling power, connections, and influence.
Mm-hmm. Right. That's great. Yeah, I think that we only showed just a real small snippet of the overall knowledge graph. I know that there's been discussion of some of those things already. My assumption is that some of them are already in the knowledge graph, and that more can be added. But yeah, I remember. Yeah. Yeah.
I was just going to say that you know, great point, and the New Jersey team, among their many other technologies, you know, have what they call a diffusion technology that, you know, if everyone was on Twitter, it sort of tracks Twitters and looks at how ideas and memes are passing through the group, and from that you can deduce a lot of information, a lot of ideas about who is influential and who is actually making a difference. So there definitely is that capability, and we definitely are open to all ideas about how, given the sort of science base that we're starting from, where most of us probably don't use Twitter that much, that how do we, without compromising people's you know, confidence in the system and trust, so we're not like surveilling everybody in their use of our system all the time, what can we do to help people understand and find the people they need to talk to move ideas ahead using new technologies?
Great. Very good. All right. Well, that was good. Now I'm starting to feel the effects of the last couple of nights catching up to me. I'm getting ready to log off. Thanks, John, for that comment, and also thanks also for joining, and thanks, Anne, for inviting you. So this is really good. And this was also a really good experience for us in getting ready for the national workshop. And I think, in fact, one of Tim's closing statements in the chat really kind of summarizes where my mind is already going, which is thanks John, Mike, Philip, and Sono. Much to discuss with the outreach team as we move towards the national workshop. So I think that might be actually a really good segue towards closing here for those of you that stayed on for a few more minutes. Thanks for doing that. If anybody else wants to continue facilitating, that's fantastic. I am going to log out now, and Philip is the host.
Thanks, John. Great job.
Okay.
Thank you very much.
Yeah.
Hey, any of our water quality people that want to, have a longer conversation, if you want to schedule a conference call or something, we'd be happy to do that. So just send me an email. This is Sono, and let me know.
All right, thanks all. I'm just going to hang up the meeting at this point, and I'm sure we'll be talking to everybody through different media going forward. Have a great day.